Hello students, most welcome to Dr. Acharya Academy. Today I am going to discuss the formation of ionic bonds. In the previous class, you have seen that how the octet rule is followed during the formation of ionic bonds. And here we'll discuss about how the energy, different types of energy is the force for the formation of ionic compounds. Today's class number is 071. This topic has been taken from the NCERT Chemistry Class 11 books. The formation of ionic bonds primarily depends on number one, the ease of formation of the positive and negative ions from the respective neutral atoms. Number two, after the formation of the positive and negative ions, the arrangement of these ions in the solid, that is the lattice of the crystalline compounds, and the formation of ionic compounds depends on these points. Now we'll see the formation of a positive ion involves ionization. You can see in this example down at M denotes generally metal in gaseous form. It will form M plus in gaseous form, one cation, plus it will release one electron. Similarly, to form the anion X, one atom in gaseous form, it will take one electron and it will form one anion X minus in gaseous forms. So final reaction is like that. Here I already told that respective energy will play a role for the formation of this type of ionic compounds. So first, the electron gain enthalpy. Electron gain enthalpy I already discussed in the unit number 3. And this electron gain enthalpy is the enthalpy change when a gas phase atom in its ground state gains an electron. You can see now this X atoms in gaseous phase in its ground state will add up with one electron to form an anion X minus in gaseous phase. The electron gain process may be exothermic or endothermic. That means during this formation, that means anion formation, it can release energy, then it will be called the exothermic, and when it will absorb the energy, then it's called the endothermic. This ionization, I discussed that from M in gaseous form, it will form the cation M plus one electron. So this process is the ionization. This ionization process always the endothermic. That means it always will absorb energy to form the cation. Another factor which is called the electron affinity. What is the electron affinity? It is the negative of the energy change accompanying electron gain. We'll give one example. Ionic bonds will be formed more easily between elements with comparatively low ionization enthalpies and elements with comparatively high negative value of electron gain enthalpy. So ionic bonds will be formed by elements which has the low ionization enthalpies to form the cation, and another elements which have the high negative value of electron gain enthalpy to form the anion. This cation and this anions will form the ionic bond. Most ionic compounds have cations derived from metallic elements. Metallic elements generally form the cations, and anions will be formed from non-metallic elements. Here one exception is there. Exception is the ammonium ion. Ammonium ion, you can see it consists of nitrogen and hydrogen. Both are non-metallic elements. But till now the ammonium ions, that means ammonium ions as a cation NH4 plus is formed from these two non-metallic elements. And this NH4 plus, this cation usually forms a number of ionic compounds. Ammonium chloride NH4Cl, ammonium sulfate NH4 whole twice SO4, etc. So these ionic compounds in its crystalline state consist of an orderly three-dimensional arrangement of cations and anions. We see in our table salt. Table salt is the crystalline state of the ionic compounds sodium chloride, which is formed by Na plus cation and Cl minus anion. And these Na plus cation and Cl minus anions, that means cations and anions, held together by Coulombic interaction energies. Now we'll see example. You can see this example. This is the sodium chloride salt structure, rock salt, and here is the Na plus in small circle and comparatively big circle. It is considered as a Cl minus anion, and here you can see that it is packed to form the three-dimensional crystal structure. That means this crystal structure depends on the size of the cations and anions, their packing arrangements, and other factors. In ionic solids, the sum of the electron gain enthalpy and the ionization enthalpy may be positive, but still the crystal structure gets stabilized due to the energy released in the formation of the crystal lattice. So, though the sum of the electron gain enthalpy and ionization enthalpy positive, but due to the energy released during the formation of the crystal structure, if it is more, then this crystal lattice will be stable. We'll give one example now. See the ionization enthalpy for Na plus formation from Na, from sodium, is the 495.8 kilojoule per mole. And for the electron gain enthalpy, for the change from the chlorine atom gaseous form, you will accept one electron to form the anion Cl minus in gaseous form. Its electron gain enthalpy is minus 348.7 kilojoule per mole. So if you sum this, then what will be the result? 495.8 minus 348.7, the result is 147.1 kilojoule per mole. Do you see, this is the positive value. But this positive value of the sum of these two energies, it will compensate by the enthalpy of lattice formation in HCl in solid form. Because during the formation of the lattice in HCl from Na plus and Cl minus, the energy will be released. How much value? 788 kilojoule per mole, and it is released. That's why this minus symbol is there. So the energy released in the process is more than the energy absorbed. Energy absorbed is 147.1 kilojoule per mole, but energy released is a 788 kilojoule per mole. So energy released is more than the energy absorbed, and in this way this rock crystal structure is being stabilized. So here one thing to see, that octet rule is not the factor. Here the energy releasing to form the final crystal state, that is the factors. So here the quality measure of the stability of an ionic compound is provided by its enthalpy of lattice formation, and not simply by achieving octet of electrons around the ionic species in gaseous state. So now another term we know, lattice enthalpy, which plays a key role in the formation of ionic compounds. So now lattice enthalpy. Lattice enthalpy of an ionic solid is defined as the energy required to completely separate 1 mole of a solid ionic compounds into gaseous constituent ions. This is what is called the lattice enthalpy. Example, previous example we'll take. Lattice energy enthalpy of NaCl, what is it? 788 kilojoule per mole. It means that the 788 kilojoule of energy is required to separate 1 mole of solid NaCl into 1 mole of Na plus in gaseous form and 1 mole of Cl minus in gaseous form to an infinite distance. So here you see what is the lattice enthalpy, definition of lattice enthalpy with example. So this process, that means formation of the lattice crystals, it involves both the attractive force between ions of opposite charge and the repulsive forces between the ions of like charge. That means cation to cation, it will give repulsive force, it will feel repulsive force, and anion to anion, it also will feel repulsive force. That means sodium cation to sodium cation, it will feel repulsive force, and chloride anion to chloride anion, it will feel also repulsive force, but sodium cation Na plus and Cl minus will feel the attractive force. The solid crystal being three-dimensional, so it is not possible to calculate the lattice enthalpy directly from the interaction of force of attraction and repulsion. Factors associated with the crystal geometry. What is the geometry of that particular crystal? That also one factor to calculate the lattice enthalpy of that crystal. I hope that you understand this topic very clearly, and how to form the different ions and ionic compounds. And in addition to octet rule, what is the other factors which will help to form ionic compounds from different ions? With examples, sodium chloride, that means rock salt structure. Thank you so much for watching this class.